Okay, so in chemistry, we need to work out the masses of different elements or compounds that will react with each other. There's a way of laying out calculations for this type of thing, which I call the tower method. So you will have been taught probably exactly the same thing by your teacher, whoever's teaching you. All this is just a way of setting out a calculation which looks tidy and also, I think, will actually guide you along the way with what you're doing. So you may get a calculation which says, for example, how many grams of calcium carbonate must be used in order to, how many grams of calcium carbonate must be used in order to thermally decompose into 28 grams of calcium oxide. Okay, so this is the sort of question that you would use. So you've got to start with an equation, all right? An equation, as in my other videos, we said we've got to get our formulae right first. So now I know that calcium carbonate has the formula CaCO3. How do I know that? Because I know that calcium forms a 2+ ion. And I also know that carbonate is CO3, which is a 2- ion. Those ions have the same charges. If I put them together, they cancel each other out. So calcium carbonate. Now thermal decomposition is, so decompose means to take one thing and split it up into two. And that happens using heat. So thermal heat decomposition, splitting up into two. If I heat this really strongly, calcium oxide. I know the formula of calcium oxide is CaO because calcium is 2+, oxygen is 2-. Can you work out the other product that we would make here? You can pause and have a think about that, but it is carbon dioxide. Now, I can see, because I'm really used to doing this all the time, so I can actually see that equation is completely balanced. But you could write out the numbers of the atoms underneath and you could actually double check that it's balanced. So we have to start from a balanced equation, okay? Now, the question has asked me how many grams of calcium carbonate must be used in order to get 28 grams of calcium oxide. So the two things that I'm interested in here are the calcium carbonate and the calcium oxide. So what I'm going to do is I'm going to draw a tower under both of these things. So one is a reactant, one is a product. You could be working here with two reactants or two products, or one reactant, one product. There's all sorts of ways around of doing this, okay? The same method will still apply. Now, I've drawn two towers. I have 4 floors in my towers. And those floors are mass, MR, moles, and ratio. Okay, same for these. I'm going to start by filling in what I know. And what I know that I want to do is I want to make 28 grams of calcium oxide. So what I'm going to use is I'm going to use this tower and I'm going to work down this tower, and then I'm going to go across to this tower and I'm going to work upwards, and I'm going to eventually work out the mass of calcium carbonate that I need to use. Okay, calcium oxide, MR of 28 grams. Sorry, mass 28 grams. Now, the MR of calcium oxide, so I need to look up the mass value for calcium, which is 40, and the mass value for oxygen, which is 16. So this has an MR value of 56. Okay, 28 grams, 56. How many moles have I got? Well, I've actually got half a mole of calcium oxide that I am trying to make. Okay, how did I get that? Because I know that moles equals mass over mR. So what I've done is I've done 28 divided by 56, and I can see that that is a half. You need to know this. Okay, with this last lesson. Right, the ratio bit. So, ratio comes from balancing. And it is basically, what you put in here is the number that you find at the front, the balancing number. Now, there is nothing written there, and that's because it's a 1. Okay? 1 mole of calcium oxide would have been made from how many moles of calcium carbonate? Well, it's 1, isn't it? So, we have ratio numbers 1 to 1, okay? I'm trying to make half a mole of calcium oxide, so how many moles of calcium carbonate did I have to start with? Half a mole. Okay, 0.5, 0.5. So basically, you work this one out and then you use this ratio to fill in that one. Okay, so if it's 1 to 1, it's going to be exactly the same number. I'll do an example in a minute that's not 1 to 1 and you'll see what I do. So 0.5, the MR of calcium carbonate. So you've got to add the masses together. Calcium is 40, carbon is 12, 3 lots of 16, totals up to 100. I want half a mole of something where 1 mole weighs 100. Require is 50 grams. And there we are. That is job done. That's the answer. It's 50 grams. Okay. Okay. So I've written another question here. What mass of hydrochloric acid is needed to react with magnesium to make 10 grams of magnesium chloride? So this is a good question. And it requires us first of all to write an equation. Hydrochloric acid formula, HCl, you need to know that one. Magnesium, metal, on its own in an equation, Mg. Now, magnesium chloride, interesting. Magnesium is 2+, chloride is a negative ion. I have to balance up these charges by swapping them. Effectively, so I need 1 magnesium ion to 2 chloride ions, MgCl2. Okay, and then I also need hydrogen, because when you react a metal with an acid you make magnesium chloride and hydrogen. So I've got an equation there that is not balanced. Okay, so I have to balance this by putting a 2 there. So now I can work on my tower. What mass of hydrochloric acid, so I'm interested here, is needed to react with magnesium to make 10 grams of magnesium chloride? Okay, 4 floors, all right, 4 floors. So my floors are titled mass, MR, moles and ratio. I can fill in the things that I know. I know I want to make 10 grams of magnesium chloride. And I also know that the ratio is 1. There's an imaginary 1 in there. I've just written it in, but it's there, to 2. So this is where I've got some numbers. I'm going to work down here and I'm going to use this ratio to take me over here. 10 grams of magnesium chloride. So the MR of magnesium chloride, this is important, the MR of magnesium chloride is actually 95, okay? It's actually 95. So how do I know that? Well, chlorine is 35.5. You add 2 of them together and add on 24. So you could do this, you would do this as a separate calculation, okay? So if I have got something, I've got 10 grams of that something, but its MR is 95. How many moles have I got? So it's mass divided by MR. Alright, moles is mass divided by ml. So I've got to do, on my calculator, I've actually got to do the sum of 10 divided by 95. Okay, if it was 95 divided by 10, it would be easy. 10 divided by 95, which gives me 0.105. Alright, I've rounded that to 3 significant figures. 1 mole would be made from 2 moles. 0.105 moles is made from 0.21. How have I done that? Because I have actually seen that that ratio doubles going from there to there, so I have taken that number and I have doubled it. I can put a 0 on the end there. Okay. Now the next thing to calculate is the MR of hydrochloric acid, so you'd be going off to do that. So it is 36.5 is the MR of HCl. Chlorine is 35.5 and your hydrogen is 1, so adding them together gives you 36.5. Now I've still got my number of moles here in my calculator, so actually what I'm going to do is I'm going to leave that in the calculator. I'm going to times that by 2, and then I'm going to times that by that, so I get 2.105 0.2105 263,157 blah blah blah. So I'm going to use the calculator value, but this is what it is rounded to 3 significant figures. I multiply those two numbers together. Multiplying those two numbers together, and I end up with an answer of 73 grams. There we go. There's my answer. Okay, so that, my friends, is how we do the tower method to work out reacting masses. Whichever way you're going, kind of doesn't matter. Now, but even if you get stuck with these, you will always get some credit for working out MRs. All right.